frame was built out of wood. We at first purchased a solenoid from the internet, but found that this was going to be too weak, so we had to create our own. We used a bolt and wrapped 1,000 turns of wire around it, and found that this was a much more successful and appropriate piece of equipment. Our small levitated object is shown below, along with the general picture of our circuit and controller. In our design, we've implemented two Hall effect sensors, one shown below the solenoid and then one shown above. For our control circuit, our group chose to use the Arduino Uno as our controller, which has been implemented as shown. The Arduino acts as the brains of our operation and allows us to check the readings on our Hall effect sensors. For the circuit components here, you can see we have four 1 kilo ohm resistors, a 741 op amp, a MOSFET, and also our two Hall effect sensor connections. Here you can see our general schematic for the circuit previously shown.
Transfer function of the process, and here we see that the disturbance and the current will both equal the force of the system, and we determine the transfer function block diagrams from these equations, and we find that the distance and the current of the solenoid and the forces that are applied, which are any disturbance forces, should the solenoid current and the disturbance forces are added together in order to create the transfer function for the distance. From this distance transfer function, we further manipulate it in order to create a controller. We chose to design a PID controller and we figured this out by testing out the different controllers, and we found that the PD or the P controller wouldn't have as much of an effect as a PID controller would have. The PD controller would work as well, but the PID controller would give us a better stability. After figuring out the PID controller, we found that we needed to set the Ki value to 0, and we need to set the Kp and Kd values according to the stability equations we found from the Rauch-Hurwitz array. And this is shown in the closed loop characteristic equation section in the report. We then designed the controller using Arduino, and we coded by using the PID library that's already given in Arduino. From this, we found that our controller affected the current enough to cause a change in the solenoid. However, our change did not result in a functional levitating device. However, it did have enough of a function to where the object was able to levitate just for a bit before the controller would not act accordingly, and the magnet would attract the levitating object and would be pulled towards it.
In order to test our Hall effect sensors, we wrote this simple Arduino code. We touched a magnet close to the Hall effect and then saw the reaction in the serial plotter window as shown. Here you can see our implemented Arduino code. We chose to import the PID library, which allows us to adjust the Kp, Ki, and Kd values as seen below. For stability, we used a Ruth array to solve for Kp and Kd values that we believe would offer the most stable levitation.